Okay, now we're going to talk about multiplying fractions. It's actually the easiest operation you can do with fractions. What you see here is a rectangle, and we're going to try to figure out what is 1/4 times 1/3. What is a fourth of a third? We want 1/4 of a group of 1/3. So imagine how small 1/3 must be. So here we have a rectangle. We'll cut it roughly into thirds, and this will be not very well. Let's try that one more time. We're going to cut it into thirds, so roughly there. Alright, and then we'll shade 1/3 of it. So there's a third of the rectangle. Now, that is 1/3. We want 1/4 of it. We want just a small piece of that 1/3. So this is going to be a very small fraction. So I'm going to go ahead and chop this into fourths, roughly. So there is 1, 2, 3 fourths, and I don't want all of these pieces. I only want 1/4 of that 1/3. So I'll go back through here and shade this. Here's that 1/4 that I want. So there's 1/4 of the 1/3. Here's 1/4 of the third. And what is that ultimately of the original whole? So we want to know what fraction that is of the original piece. So I'll just extend these lines that I had made there. Okay, this is not perfect, I know, but you get the idea. So I take a look at it and I'm like, well, I have 12 total pieces, and the piece that I ended up with when I had a fourth of a third is just this small corner. Oh, so that's only 1/12. Therefore, 1/4 rather of 1/3 must be 1/12. And there's picture proof of it. Now, what's going on mathy-wise here is you may notice that 1 times 1 equals 1, and 4 times 3 equals 12. Is it really that easy? Yeah, with multiplying fractions, it is that easy. You just multiply top times top and bottom times bottom. So here is a sample problem. It's on page 6, number 3. It is simply top times top, boom, bottom times bottom. Now you look at the word of. Does that mean multiplication? Yes, it does. Think of groups of. So I want 1/9 of a group of 2/3. So we start with 2/3. That's pretty small. And I don't even want all of that. I only want 1/9 of that 2/3. This is going to be a very small answer. So our fraction piece for an answer should be incredibly small. So we multiply straight across. And 1 times 2 is 2. 3 times 9, 27. And like we thought it would be, a very small answer, 2/27. So of the original whole, we started with 2/3 of the original piece. Now we've cut it into 27 pieces and taken just 2 of them. That's very small. Go to the next problem, number 4 on that same page. We multiply straight across. So 2 times 1, multiply straight across. 2 times 1 is 2, and 7 times 2 is 14. And then you look at that and say, wait a minute, that's not in simplest form. And we like to give our answers in simplest form whenever possible. So both those are even numbers. They're divisible by 2. So I'll divide the top and bottom by 2. Hopefully I got enough room to write here. So divide by 2, that would be 1/7. Now there is an easier way to handle this. So let me erase the marks that I made if I can. Evidently I cannot. So we'll just start over down here. Same problem. 2/7 times 1/2. So 2 times 1, what's happening here is 2 times 1. And 7 times 2. Okay. Now you may notice there is a common factor right here and right here. So I can just divide it out right now instead of waiting to simplify like we did up here. Instead of getting the answer and then waiting to simplify, It's actually easier to simplify here. Okay, take out a 2, take out a 2, and therefore I don't have to go to 2/14 and back down. I just pull those 2's out right now, and I have an answer of 1/7. All right, next problem, number 5 on page 6. This is a full whole number, 6, being multiplied by 5/8. So now think, if this was 1 times 6, I want one full group of 6, the answer would be 6. But it's not, it's only 5/8. So I want a little bit more than half of 6. This answer is going to be bigger than 3, but somewhere 3 and some fraction. It's going to be a mixed number of 3 and some fraction. All right, so what we're going to do here is remember any whole number can be turned into a fraction by just setting it over 1. So we just put it over 1 and we multiply straight across. So 5 times 6, boom, 8 times 1, boom, and that'll be our final answer. Now we can pull out common factors here. See, that's 6 and 8 right there. Those both can be divided by 2. They're both multiples of 2. So I will pull out a 2 here, divide by 2. That would be 3, and divide by 2, and that would be 4. Multiply straight across. I'll put my answer down here. 5 times 3 is 15, and 4 times 1 is 4. Now this is an improper fraction. Got to turn it back into a mixed number. 4 goes into 15 3 full times. So I'm actually writing backwards here, but that's all right. 3 full times, with a remainder of 3. So that would be, now the remainder is what? The remainder that's left over is fourths. So that is 3 and 3/4, which is right where we thought it would be, a mixed number bigger than 3. Alright, and finally, next problem over, number 6. We can simplify. Actually, we don't have to go through this whole process of 3 times 4, 4 times, and then divide it out. We can simplify in the original problem. So if we're going to look for some common factors this way, all right, now, normally what would happen is we'd do 3 times 4, and we'd write it 3 times 4, and 4 times 7, and we'd write it, and we'd divide out the 4s. Well, let's just cut to the chase. Remember, math is a lazy subject, or as we like to say, efficient. It's a very efficient subject. So we're going to simplify now. We're going to look right here and say, look at these 4s. These are both obviously have a common factor of 4, so we'll divide by 4 each way. So I'm going to divide this by 4. That's 1. Divide this by 4. That's 1. Now I'll multiply straight across, and I will have my final answer. The great thing about simplifying here in the problem is that your answer will be in simplest form. Also, too, you should look the other way. 3 and 7, those are both prime numbers, so they do not have any common factors. So I'll multiply straight across, and 3 times 1 is 3. 1 times 7 is 7. Answer quite simply is 3/7.